Okay, so now we start with the A level. Circular motion again.
Okay, sir.
We will talk about the so there are linear and there are angular discussion. Linear displacement have a unit of meter. Angular displacement have a unit of radian. Radian means the angle moved by how much, right? Linear velocity unit is meter per second. Angular velocity, the unit is radian per second. Angular velocity, the term is also known as angular frequency, or can be written as omega. Omega, the symbol is like W. Not the unit, the symbol, understand, right?
Okay, sir.
Then we have
Yes,
linear acceleration, meter per second, -2. And we have angular acceleration, or known as alpha. The unit is radian second, -2. You know angular displacement, right? Like the mathematics, huh? So, for example, I say you know how to find arc length, right?
Yeah.
Yeah, so linear displacement actually is arc length. Because it's like this, right?
Linear.
So this is 1 meter. This one is 0.2 radian, I think. So when I say angular displacement, it means how much the angle changes. So how much the angular displacement?
0.2. Wait,
Yeah.
0.2. Then
So if I ask you for the linear displacement is only as simple as how much the arc changes. So the arc length is theta times r. So it becomes 0.2 meter also in this case. How, we have any questions?
no, sir.
No.
So the linear displacement always the arc only, sir.
Yeah.
Okay, sir.
Okay, sir.
Now we got another one, another note. So for angular velocity, or also known as angular frequency, the formula is the angular displacement divided by time, right? Understand what I'm talking until here?
Yes, sir.
So if I say the time is 1 period, or if I call the time as period, it means the displacement have to be what? Have to be one waveframe, or I can say one full circle.
So,
You have any things you like to ask until here? When I say when I say the time is a period, it means it finishes one motion. One motion means one circle. Enrico, Pinson, understand?
yes, sir.
So if I say one full turn, how many pi is it?
2 pi.
2 pi. So now the formula for the omega or the angular velocity also can be 2 pi over period.
2 pi.
If the time you use period, then the angular displacement is 2 pi. Understand?
Yes, sir.
And 1 over period is
Frequency.
frequency. So another formula is also 2 pi times
Frequency.
frequency. Any questions until here?
Yes, sir.
questions? I clear the board.
Good, sir.
Photo. Later I send you the link also. If you wanna re-listen again.
Okay, sir.
Sorry, disconnected, sir.
Okay. You wanna photo the board first?
Yeah.
Okay, I clear.
Wait, sir, wait, sir.
Okay, sir.
Okay, ready? Everyone okay?
Okay. Yes, sir.
Next, for circular motions, where does the centripetal force go?
The center.
Yeah. Forces, centripetal forces, both force and accelerations always head to the center. Okay.
Okay, sir.
To count centripetal acceleration, the formula is given by omega square times r. Or it could be v square over r. So v square is the linear speed, right? If omega is angular velocity. So I give you another example again. Yeah, not sure about the centripetal force. Let's say question number one. Let's say our clock. Calculate the angular. Yes.
Vincent disconnected, sir.
Yeah. Okay. So let's say at a clock, he asks you to calculate the angular velocity of the minute hand for 1 hour. So if I say 1 hour, your minute hand travel how many circles? How many full circles travel by the minute hand? How many circles travel by the minute hand?
One circle.
One circle. So the period is 1 hour, which is equal to 3,600 seconds.
Sorry, sir. So lagging, sir.
It's okay. So the angular velocity is 2 pi over 3,600 radian second negative 1. Anyone want to ask questions until here?
Hand travels. So, oh, wait, sir.
Sure, see this for a while. If no questions, I'll continue.
So just now the formula is angular velocity over frequency or angular velocity.
Angular velocity is omega. Omega is 2 pi times it. Omega is 2 pi times 2 pi over t. Uh, 2 pi over t or 2 pi times n squared. Any questions here?
No, sir.
Okay. Continue first. Yeah.
Okay, sir.
Later baru copy or
Later after this full board, I'll let you take picture of it.
Okay, sir.
But later I will share the link. Don't forget to subscribe.
Okay, sir. Okay, sir.
We have YouTuber already.
Yeah.
Turn to be a YouTuber. Oh my god, this one get recorded. Oh, I cannot share the school. Not get censored. This one. Okay, calculate the centripetal acceleration if the stone is being swung in a circular motion. So to calculate the centripetal acceleration, the formula is given by
Omega
omega
square.
square times r, right? Let's say, let's take the time or the period as, let's say, 2 seconds or 10 seconds. So the question actually have to tell you. So the acceleration is equals to, we find the omega version. The omega is 2 pi over t. The t is 10. So it becomes 0.2 pi. So now the acceleration is equals to omega square times r, right? So 0.2 pi square times r. The r is 2, so it's 0.79 meter second negative 2. Any questions until here?
No, sir.
Oh, okay. You can take which of the board version.
So this one first chapter or?
First chapter. Yeah.
Oh, okay.
So, later the pure maths at 2 o'clock, right? So,
Yeah.
we have Miss Dodi class until 2:30 also.
Google Class or what? Yeah. Not sure.
Google Class.
Google Class. Google Class don't have this video. Right?
Don't know. Skip aja.
Oh,
Google Class, I think do homework only. Yeah.
oh, one Google Classroom aja kan? Not Zoom, right?
No.
Oh, okay. Okay.
Okay, so if you want to count the centripetal force is 0.2 times 0.788.
0.2.
0.2 times 0.78. So the centripetal force is 0.156 Newton. Do you have any questions until here?
No, sir.
No, sir.
Okay. Continue
Oh,
again.
Google Class aja. Okay, okay.
Now, what you have to understand is, if you really do these things here, the centripetal force is the resultant force here. The centripetal force is the resultant force. So let's say the questions continue again. Let's say that is A again. And then let's say the question asks you to find the tension in A. So for example, the next question asks you to find the tension at point A. So the centripetal force that you have found, right, that's the resultant force. So centripetal force is equals to resultant force. So in that part, how is the resultant force be? If I say tension minus weight, do you understand?
Yes.
Tension. Yes.
So the tension in every point will be different. So the weight in this case is 0.2 times 9.8. So the tension in every case will be different. So if I ask you to calculate the tension at point B, how would it be? It means the centripetal force always stay the same. So the centripetal force now is it equals to tension minus weight again?
Wait.
It will be tension plus weight.
Plus weight.
Why? You have to understand in this case, okay? So the acceleration that I count just now, I take the value as positive, right? The value error as a positive sign, is it? Where does the acceleration always go?
Towards the center.
Okay, good if you understand that. Now, pay attention at here. Your tension and the weight also go to the center, right?
Yeah.
Your acceleration also go to the
Center.
center. Because the accelerations you take as a positive result already. So means the tension and the weight also have to be positive. Anyone ask question until here?
Just now previously what yang positive already, sir? The first one.
The accelerations I assume as positive.
Why?
The acceleration I assume as positive at here. So if the acceleration is positive, it always head to the center of the circle, right? So means all of the forces, all of the acceleration that head to the center of the circle must be positive also.
Oh.
So in this case, your tension and the weight is going down, right? Which is to the center of the circle. Your acceleration also going down. So everything have to be positive. So 0.156 is positive. Plus 0.2. So of course the tension will be the least at that point. You understand? Tension will be the least at that top part. If you think in a common sense or not. So you got anyone ask questions until here?
No, sir.
No, the answer is a negative value. So don't mind the answer. I mean, just mind the working.
Okay.
So okay until here?
Yes, sir.
Sir,
Yes, yes.
2.1 get from where?
The what?
The tension 2.1.
The tension 2.1 because it's 0.156 plus the W.
Okay.
Any questions?
No, sir.
No, okay, getting harder again. Actually, if your vector's okay, then that's okay. That's at point C now. Now let's say this angle is 60 degree. So you have to draw the free body diagram. So now these things, the tension is to this case, right? Your centripetal force also to this side, right? But then our weight is to this side, is it?
Yeah.
And this one is how many degrees just now?
60.
And here also
60.
60 degree. Understand? So means this one is W sign, right? But do we need a W sign? What component do we need? We need to decide one of them, right? Which is also what? W
Sin 60.
cos
Oh.
68. Understand?
Okay.
So all of them head to the same directions, right? Will any of them be negative?
No.
So centripetal force equals to T plus W times cos 68. So T is equals to centripetal force minus W times cos 60. Can understand?
So,
Before I clear the board, any question, please?
the unwind, what's the FC, the answer?
Sorry?
The F, what then? FC.
FC is centripetal force.
Okay.
Any question?
No, sir.
Okay. And number 3. Now let's say if you hang the object in this position, then you move it this way. So means this one will be the tension, right? Let's say this is 60 degree. Okay. So now the first question is that the question say the mass of the object is 0.2 kilogram. The length of the rope is 1 meter. Then let's say the question asks you to calculate the weight. After that, let's say the questions ask you to calculate the omega. And the last one is the centripetal force. And the radius not given. Okay, so let's say from that information. So if your object being string like this, right, does it move vertically?
No.
No, so there is one component here, which is equals to T sine 60. So it means the T times sine 60 have to be equals to
The weight.
you understand here?
Yeah.
So the T is 2.26 Newton. Then for the omega, 2 pi over period, right? Let's say the period is, for example, 5 seconds. So it means you get 0.45. Everybody understand here? To find the centripetal force, I count the acceleration first here. Oh, no need acceleration. For the centripetal force here, the centripetal force is given by what? Given by the T times what?
Cos 60.
Yeah, because it's the only force that head to the center. It's the only force that head to the center. So means for this case, right, the centripetal force is provided by the T times cos 60. Other information not really important anymore. So any question you guys would like to ask?
No. So may explain once more the omega formula for mine, sir? It's not quite clear.
Omega, oh, okay, sure. Omega is 2 pi over period. Just I give you this formula because omega is given by angular displacement divided by time. So let's say the time is 1, or I call it as a period. So it means the angular displacement must be equals to 1 full circle, 1 full turn.
Oh.
In 1 full turn, how many radians are there?
2 pi. 2 pi, right?
2 pi, right? Yeah, so 2
Yeah.
pi over t. I understand now? Does it become 2 pi over period?
Okay. Thank you, sir.
Welcome. So can you take picture of the board?
Okay, sir.